Okay. So in case of ring counter, if 4-bit ring counter, 4 flip flop, 4D flip flop. Now the design is how they design it is. The next flip flop is connected. The next flip flop input is connected with output of previous one. You can see the next flip flop input is connected with the output of previous one. Is it okay?
Yes, sir.
And the last flip flop output is input to the first one. Okay. So this is all about the inputs. Next is here, this flip flop is synchronous flip flop. Synchronous means all the clock pulses are connected with same clock. So this is the synchronous flip flop. All the clock terminals is connected with same clock pulse. Okay. Next is there is the preset and clear terminal. This is the clear terminal. Clear. What is the use of preset and clear? We already discussed in the previous classes. Anyone? Dipanjan, what is the use of preset and clear?
Sir, I don't know.
Acha. You can see here. This preset and clear terminal, use of preset and clear is what? Pritha bolbe? Yes, no?
হ্যাঁ স্যার, হ্যাঁ স্যার,
হ্যাঁ বলো।
ক্লিয়ারটা হচ্ছে মানে প্রথমে যদি জিরো দিই তাহলে প্রত্যেকটা জিরোই থাকবে, আর মানে প্রথমে জিরো থাকবে, দেন যদি আমি মানে চেঞ্জ করি ইনপুটটা তখন তাহলে ওটা চেঞ্জ হয়ে যাবে প্রিসেটের দিয়ে।
Yes.
মানে করি
This,
যখন।
yes. This preset and clear is used for preset and clear. This is used for set the initial output of flip flop. Initial output টা 0 রাখতে হবে বা 1 রাখতে হবে। It is depend on this preset and clear. So if you want to set the initial value of output is 0, then you connect the clear terminal with ground. Okay, connect the clear terminal with ground or 0. It will be 0. Clear? Next, if you after that, for the normal operation, means when you are use this flip flop for the operation, this all preset and clear is connected to VCC. जब उसको normal operation में use होगा, it is connected to VCC. Clear? So same here, for the normal operation, जब इसको use करना है, this preset and clear is connected to VCC. Okay, for the normal operation. Next is this ring counter is also called shift register counter because here the data is shifting. Data is shifting. Now suppose here in this case the initial value of is 1000. So suppose initially here the out this data is this one. Initially set the data as 1000. Okay, here this is 0. Q0 is 0 means, so at the initial condition when clock 0, your x3 is 1, q2 0, q1 0 and this is 0. So at the initial condition, suppose we set this value at 1000. Okay, after that when you supply the next clock pulse, when is this clock pulse, at that time this 0 is the input here. Okay, 0 is the input here. Now when you supply the clock pulse, so here it is 0, so after that it will be 0, and this is 1 to this flip flop, this will be 1, and previously this 0 is proceeds, here you are getting 0, means whatever the data, this data is shifted by 1. Is it okay or not?
হ্যাঁ স্যার।
Okay. Suppose this is the initial condition. So here the input output is 1, 1, 0, 0, 0. So this 1 is input to this one, this 0 is input to this one, this 0 is input to this one, and this 0 is input to this one. So when you apply the clock pulse, this data is shifted to this side, this data is shifted to this side, this data is shifted to this side, and this data is shifted to this one. Clear? So after the first clock pulse, your data is your input. This data is shifted. This 1 will be Q2, 0 will be Q1, this 0 will be Q0. So after the first clock pulse, you are getting this value. Okay. And again, for the second clock pulse, again this 0 will be the input to xi, to here xi. So this is shifted to this one, this shifted to this one. For the second clock pulse, again this one is shifted to this one. So all bits are shifted by 1. So here, after each and every clock pulse, the data will be shifted. This data is this one, this is shifted to this one, this data is shifted to this one, and this is shifted to this. So this shifting is shown in this table. Clear? After third clock pulse, here the input is xi. Okay. This data will be shifted to this one. This is shifted to this one. So each bit is shifted by 1. And you can see after the fourth clock pulse, here again it is 0 input, and you are getting same data as the initial data. Same data as the initial data. Okay. Means how T state is required for getting the same data. Mane kya ki after this four clock pulse, if you provide the fifth clock pulse, so again you are getting this one, after that this one, after that this, means after this 0, 1, 2, 3, 4, after that you are getting it is repeated. Okay. So here the number of state after which the day it will be repeated is 4. By using this pulse, by using this counter, you can count maximum up to n state. N state means how, if the number of flip flop is n, you can count maximum 4 pulse. Clock 1, clock 2, clock 3, and clock. After that, it is repeated here. You can see. उसके बाद क्या हुआ? फिर पहले वाला ही चलाएगा. अगर इसके बाद फिर क्लॉक पल्स दोगे तो फिर ये वाला रिपीट करेगा. फिर क्लॉक पल्स दोगे, this one. Okay, so it is repeated after the n. Number of state means how many state it can count. So it can state here, this counter can count maximum n number of state. If the flip flop number is n, here it is 4 number of flip flop. So here 4 count is there. This is first count, second count, third count, fourth count. After that, the count will be repeated. Is it okay or not? समझ में आया या नहीं? Okay. Now suppose this n count, for each and every count you need the clock pulse. So suppose if the one clock pulse required t time, one clock pulse required t time, then how many the total time is required for this one cycle, one counting, one complete counting is nt. After the nt cycle, it will be again repeated. So here the time required for this counting, yeah, maximum kya n counting. So for counting this, you require the n into t. For one count, you require t second. So for n count, n into t. Okay. Total time required for counting the ring counter is nt. Next is what? The data, this waveform. This is the data shifting in ring counter. How the data is shifting, it will be shown in the table. Next, you can see whatever the status of this shifting, it is shown in the clock pulse. So suppose this is clock 0, clock 1, clock 2, clock 3. Your xi, you can see, your xi is xi status is for clock 0 it is 0, clock 1 0, clock 2 0. So you can see your xi is 0 0 0 up to clock 2. Okay, up to clock 2 your xi is 0. Then for at clock 3 your xi will be 1. So here it is 1. Then clock 4 again it is 0. So after that it is 0. Okay. Same for your Q3. Initially means 0 clock it is 1. Next it is clock 1 it is 0. Then clock 2 0, clock 3 0, clock 4 1. So here your clock Q3 is initially for clock 0 it is 1. Then it is for first clock pulse 0, 2, 3, and last it is again for clock 4 it is 1. Okay, so this is the draw of wave. Same way your Q2 is, you can see your Q2 first it is 0, clock 0 it is 0, then at clock 1 it is 1, data is shifting, then 0 0 0. So here at 1 it is 1. So for Q2 you can see at 1 clock pulse it is 1 here, clock 1 it is 1, and previous and after it is 0. This waveform is from the table. Same for you Q1, you can see Q1 is at clock 0 it is 0, at clock 1 it is 0, clock 2 it is 1, and after it again 0. Your Q1 is 1 at clock 2. Your Q1 will be, you can see 1 at clock 2. This is clock 2, it is 1. Then before that it is 0, after that it is 0. This is the waveform. Same for the Q0, you can see in first clock 0, clock 1, clock 2 it is 0. At clock 3 it is 1. Then again at clock 4 it is 0. Clock 3 it is 1, you can see. So your Q0 is 1 at clock 3. At clock 3 it is 1, and before that it is 0, and after 0. So this is the waveform for the ring counter. When you apply the this 1 0 0 is your initial input. Okay. So this is a complete process of ring counter. If you have any query, you can ask. Or it is clear? Srijita, বুঝেছো? Harsh?
স্যার ওই লাস্ট লাইনটা কি বললেন?
Last line. Waveform. For this Q0, you can see for clock 0, it is 0. Clock 1, Q0 is 0. Clock 2, Q0 is 0. Clock 3, Q0 is 1. And clock 4, it is 0. So Q0 is 1 for clock 3. So you can see in the diagram for clock 3, you can see this is the clock 3. Clock 3 it is 1, and before that it is 0, after that it is 0. Okay. Here in this case, this is what type of clock pulse is there? Anyone? What type of clock pulse is? Yes, this is the negative clock pulse. Yes, we already discussed the symbol for negative clock pulse is like this. Symbol for negative clock pulse, and symbol for positive clock pulse is like this. This is the negative clock pulse, and this is the positive clock pulse. You can provide the negative, you can provide the positive. Difference क्या होता है? Negative, positive. We already discussed. No, everyone? Yes, no?
Yes, sir. Yes, sir.
Dipanjan? Yes, no?
Yes, sir.
Okay. Okay, then I will not repeat this. So I think this topic is clear. Can I move to next topic? Yes, no? नेक्स्ट टॉपिक ए जाबो तो
হ্যাঁ
ओके ठीक योर नेक्स्ट टॉपिक इज जॉनसन काउंटर और ट्विस्टेड रिंग काउंटर ठीक तो एबार डायग्राम इज सेम diagram same explanation same you can see this is CR and preset and clear terminals for the operation normal operation it is connected to VCC before that for whatever the initial value of output it is uh, decided by the this clear terminal if all the set to 0 this clear terminal is set to 0 or ground okay now here you can see in the previous case I provide the negative clock pulse but here we provide the positive clock pulse we can use the negative no issue okay you can use negative you can use positive just for the difference I provide here the positive clock pulse okay here positive clock pulse okay so this is also synchronous means all clocks are connected with same pulse all clock terminals are connected with same pulse here this case this is 4-bit Jhonson counter or twisted ring counter so for 4-bit designing of the 4-bit Jhonson counter you need 4 D flip flop 4 D flip flop जैसे पिछला बार लगा वैसे ही here the output of sorry the input of next flip flop is connected with output of previous one जैसे पहले था वैसे ही the input of next flip flop is connected with output of previous one है ना Q3 is connected to Q2 Q2 is connected to D1 the input of next is connected to output of previous this is already connected to Q1 okay difference is where here the output of last flip flop here Q0 is connected to input of first one Q0 bar sorry Q0 bar is connected to input of first one previously Q0 is connected here Q0 bar is connected okay in case of ring counter the count value is maximum what in case of ring counter kitna tha count value in case of ring counter count value is if the number of flip flop is n then you can count maximum n count so previous case we use the 4 flip flop we count maximum 4 count okay here in case of Jhonson counter the count value is increased in case of Jhonson counter or twisted ring counter the count value is increased design just previous में क्या था Q0 is connected to input here Q0 bar is connected to input this is the difference और कुछ नहीं बाकी same now what is the effect here you can see here suppose here initially all this Q3 Q2 Q1 is set to 0 value all is set to 0 value okay so initially this all is set to 0 value means here you are getting the 0 means here initially all is set to 0 okay so at clock 0 all Q3 is 0 Q2 is 0 Q1 is 0 and Q0 is 0 now when you supply the first clock pulse so when you supply the first clock pulse your this input is what input is here 1 so when you provide the first clock pulse this 1 is processed and here you are getting the 1 and this 0 is processed here you are getting 0 this 0 is processed here 0 this 0 is processed here okay so for the first count you can see this 1 is shifted to here this 0 is shifted to here this is shifted to here this is shifted to here You can see in the diagram. This one is for the first clock pulse. This one is shifted to here. This 0 is shifted to here. This 0 is shifted to here, and this 0 is shifted to here. So for the first clock, this will be the output 1 0 0 0. You can see here 1 0 0 and 0. Next, for second clock pulse, again here it is 1. So again the input is 1 here. So for the second clock pulse, again this one is shifted to here. Means here again a 1. This one is the input to this one. So this is one is shifted to here. Here it is 0. So this 0 is shifted to here. Here it is 0. So this 0 is shifted to here. So for the second clock pulse, you can see here. For the second clock pulse, this one is shifted to here. This one is shifted to here. This 0 is shifted to this 1 bit shifting. This 0 is shifted to here. So for the second clock pulse, this is the output. Same for the third clock pulse. Again, your input is 1, and this one is all 1 is shifted. This one is shifted to here. Your input 1 is shifted to here. This is shifted to here. 1 bit shifting. Okay. After that, this third clock pulse, when you supply the, you can see when you supply the fourth clock pulse, this one is shifted to here. Here all ones. So after the fourth clock pulse, here all 1 is there. All are 1. After the fourth clock pulse, all 1. So if all 1, this Q bar is 0. So this is 0. Okay. So after the fourth clock pulse, you can see at fourth clock pulse, all these are 1. And when this is 1, your input will be what? 0. This is 0. So this is shifted to this. So here your input is 0. Now at fifth clock pulse, again this 0 is shifted to this. This 1 is shifted to this. This 1 is shifted to this. This 1 is shifted to this. So at the fifth clock pulse, this is the output data. Again, you apply the next clock pulse. Again, this is shifted. These all bits are shifted by 1. So this is the, and by the same method, at the 8th clock pulse, you can see you are getting same output as the first one. After that, if you provide the next output, again it is repeated. So by using the, you can see here, by the after the 8 clock pulses, the data is repeating. Okay, so you can count here maximum 8 clock pulses by using this count. For this counter, 8 clock pulse. So 8 clock pulse means here you are using the 4 beat, or you can see you can use the 4 flip flop here. Okay, 4 flip flop here you are using. So for the 4 flip flop, you can get the 8 pulses. You can count the 8 pulses. If you use the 4 flip flop, means 4 beat, then you can count the 8 pulses. Means if the n flip flops are used, then your 2n will be the states. How many states you can count? 2n. If n is the number of beats or n is the number of flip flop, then 2n state is there. Means 2n, up to 2n you can count here. In the previous case, the count value is n. जितना flip flop होगा उतना ही count होगा. For the ring counter, you can see the number of flip flop is 4. The number of count value is 4. But in case of Jhonson counter, if the number of flip flop is 4, so count value is what? 2n, means 8. If the number of flip flop is 3, so 3 into 2, 6. If the number of flip flop is 2, 2 into 2, 4. So count value is double to number of flip flop. So by using the Jhonson counter, the count value will be double with respect to ring count. Okay. Next, same this waveform is showing in the here. You can see xi. For clock 0 it is 1, clock 1 it is 1, clock 2 1, clock 3 1, clock 4 0. So this is shown in the diagram. Okay. So you can see up to clock 3 it is 1. So up to clock 3 it is 1. Then from clock 4 it is 0. So it is 0. और clock 8 से तो ये repeat हो जा रहा है. It is same your Q3 at clock 0 it is 0. Then after that up to clock 4 it is 1. So your clock 3 is this is 0. At clock 0 it is 0. After that it is 1 up to clock 4. Then from clock 5 it is again 0. So it is shown in the diagram. From clock 5 it is again 0. So it is 0. Same for clock 2, Q2. Q2 you can see at clock 0 0, clock 1 0. From clock 2 it is 1. So you can see your Q2 is clock 2 it is 1. Before that it is 0. And from clock 2 to clock 5 it is 1. After that 0. Your Q2 is clock 2 to clock 5 it is 1. After it again 0. Clear or not? Same you can draw the waveform for Q1 and Q0 as discussed in the table. Clear? Same data bolam setai. For the Jhonson counter, count value is 2n. If the n flip flop, then it will be 2n clock pulse. It can count. The number of state, how many state is there? 2n state, as discussed here. 2n is the state. How many states are there? 1, 2, 3, 4. Money up to 7. 0 to 7 means 8 states is there. After that, it is repeated. Okay. So this is 8 states are there. 2n or 8 for the 4 flip. Clear? This topic is over. If you have any doubts, you can ask. एक चीज मैं ऑलरेडी डिस्कस कर चुका हूं, लेकिन फिर भी काफी लोग शायद भूल गए होंगे. पॉजिटिव क्लॉक पल्स और नेगेटिव क्लॉक पल्स. इन केस ऑफ पॉजिटिव क्लॉक पल्स यू कैन सी योर वैल्यू इज चेंजेस एट, देखो यहाँ 0 से 1 हो रहा है, तो इट इज हियर इट इज 0 एंड देन इट इज 1. तो जब 0 से 1 में जब चेंज हो रहा है, तो इट इज वैल्यू इज चेंजेस एट दिस पोजीशन फॉर positive clock pulse. But for the negative clock pulse, again, suppose this is the clock pulse 0, then यहाँ 0 से क्या हुआ? It is 1. Okay, this is one clock, one time period. So here for the positive clock pulse, your value is changes at this time, and for the negative clock pulse, the clock is like this. After that, this is 1. So this is 1 to 0. Transition is from 1 to 0. यहाँ पे 1 हो रहा है और 1 से 0 हो रहा है. So during the down transition 1 to 0, for the negative clock pulse, this is the transition. So this is for the negative clock pulse and this is for the positive clock pulse. You can see, compare the both previous diagrams. For the positive clock pulse, ये 0 से 1 में जब transition हो रहा है, this is the age for the positive clock. For negative clock pulse, you can see here this is the negative clock. ये 0 से 1 में transition हो रहा है, means this is the age. For the negative clock pulse, the count value will be changed at this time. Positive में क्या होता है? यहाँ पे होता है, और negative में यहाँ पे होता है. Is it okay? पॉजिटिव में ये है नेगेटिव मैंने 0 से 1 हो रहा है मीन्स दिस वन, और नेगेटिव में 1 से 0 हो रहा है दिस वन. क्लियर इट इज. वैल्यू चेंज कहां पे, ट्रांजिशन कहां पे हो रहा है. ओके, आज के बस. If anyone have any doubt, you can ask. Anything is required to repeat? Yes, no?